All right, let's finish this up here in the last video. Should be somewhat quickly. We just said that the 1 and A, these triangles are congruent because it had side angle side similarity. I'm going to clear my ink and do B and C. All right. In B here, we have this angle here, E, is congruent to angle E, or a different way of saying it, AEB is congruent to DEC because they are vertical angles. And you could also say that D here, angle D, is congruent to angle A because those are alternate interiors. And you could also say that angle B here is congruent to angle C. All right. Even with all that information in here, though, we still cannot say that these triangles are congruent. We can say that these triangles are similar. They have angle-angle similarity. They have angle-angle similarity, but remember, angle-angle is not a type of congruency. And so these are not congruent. These are not congruent triangles. Okay? They do have the similarity, they have all those angles, but no side lengths, and we always need at least one side length to have congruency. All right? Last one here, I'll clear the ink of this one. We have triangle DEF and triangle ABC. We're going to first use the triangle sum theorem to find out what that missing angle is. So what I need to do is figure out, I'm going to take 180 and I'm going to subtract away the other angles for this triangle right here, DEF. So I'm going to start with 180 because that's the that's the sum of the angles of a triangle, interior angles of a triangle. Subtract out 45, subtract out 62, and that leaves me with a 73-degree angle here. All right. If I do that for this triangle here for ABC, I take 180, I subtract out the 73, I subtract out the 62. That leaves me with a 45-degree angle right there. Okay. If you look here, we have a 45, the side length 13, and another angle 62. And if you look on our other triangle, we have the angle 45, the side length 13, and this angle here, which is 62. And so these triangles are congruent. These triangles are congruent. You can say that triangle DEF is congruent to triangle, let's match this up, ACB. Sorry for the messy handwriting. These triangles are congruent like the first one through side, angle, side congruency. All right, and those are the three ones there, A, B, and C. A was congruent, B was not, C is. All right, the last one here, it's kind of just reading these statements. And it does help to draw them out, but it also helps just to read the statements and know what they mean. And so we'll move on to this one here. Complete these following statements. If triangle YSR is congruent to NVD, then DV here in that statement must be congruent to RS. And so the first part in A is that DV must be congruent to RS, and I'm really just getting that out of the statement that they had written there. Okay, it's also saying that measure angle RYS must be congruent, so that's angle Y must be congruent to angle N from that statement there, and they're writing it RYS, and so I'm going to write this one as measure angle RYS is congruent to, sorry for the messy handwriting again, measure angle, make sure I write this right, I believe it's going to be DNV. Okay, and again, I just took that one out of the statement here. I took that one out of the statement. All right, let's move on to B. B is one that I'm going to draw out here. So we have this angle here, DAC. We have angle DAC is getting bisected by this line AB. Okay, and so I'm going to draw the angle here. We have, this is the angle, I'm kind of cutting it off here, I gotta get rid of this. You have DAC. That angle is getting bisected, and bisecting means it cuts it perfectly in half by this line here, AB. All right, and when you bisect something, it cuts it in half perfectly. So that angle is getting cut perfectly so that this side is now congruent to this side. So the statement they're looking for is if that's getting bisected, that means that angle DAB is congruent to angle CAB, because that angle got bisected, and that's what they're looking for in part B. Okay, in part C, it's saying we have triangle WQY, that the angles WQY is equal to the angle QWY. So let's draw that one out too. We have a triangle here. You have that W, I gotta label this right, WQY. W, maybe we'll do W, Q, and Y. Okay, so WQY, this angle is congruent to QWY. So QWY, W is the angle. All right, and these two angles are congruent to one another. Well, that means that this is the only case where that happens is if we have an isosceles triangle, and whenever you have those two angles, they create, or whenever those two congruent angles, they create two congruent sides. So that angle W is creating this side QY, and that angle Q is creating this side WY, and they create those isosceles sides, or those congruent sides. So what they're looking for there is if those two angles are congruent, that means WY, that side WY must be congruent to the side QY. And that's what they're looking for in part C. Last part here in part D, ABC is a parallelogram, and I'll try to draw that out. Your ABCD is a parallelogram. And it's not bad. This is A, B, C, and D. They're telling me that angle B is 148 degrees. And they're looking for what is angle C. Well, they're looking for angle C? Oh, I labeled this wrong. My bad. This has got to be, sorry. This is going to be written like this instead. This is AB, this is C, this is D. I just wrote it wrong. Okay? Well, what we know is that in a quadrilateral, which this is a four-sided shape, the sum of the interior angles has to add up to 360. All right, so all these angles got to add up to 360, but we also know it's a parallelogram. And opposite angles, or the angles that are across from one another in a parallelogram, are equal, which means B is equal to D. And so this is also 148. And now we got to try to find out what angle A is, or angle C, because like I said, angle A is going to be congruent to angle C by the fact that it's a parallelogram. So what I'm going to do is I'm going to say, well, all of the angles added together equals 360. Let's subtract out the two angles I know. Let's subtract out 148 from that, and let's subtract out another 148 from that. And what that gives me, let me use my calculator quick, 360 minus 148 minus the other 148, that means I have 64 degrees left. All right? Well, that 64 degrees needs to be split equally into A and to C. It's got to be split equally two ways. And so what I do is I take 64, I divide it by 2, and I get that that's 32 degrees. All right? So I took the remaining amount of angles we had left, the amount of degrees we had left, and I split it evenly because A and C are equal, and that tells me that angle C must be 32 degrees. Okay, 32 degrees is my answer for part D. And that's it. Sorry it went a little bit longer than I wanted it to, but there is the lesson for the closure. The rest of the problems are going to be for the homework. Make sure you do that homework and turn it in through Cami, and you'll be done with the lesson for today.